Okay, ladies and gentlemen, today we're going to do the introduction to the product rule. You have a form. So as we do the product rule, before we do that, I have while we do that, I have a handout for you with 4 questions on it. You're to fill those out and turn those into the sub, and lets me know you completed this stuff on the video. Now, the first question on the form is just a little bit of a review. Let's talk about the rules we already know about for derivatives. Okay, the first is the power rule, that ax to the n. I almost don't like saying it this way because it gets a little complicated. Is n ax to the n minus 1. All that means is if you start out with 10x to the 6th, the derivative is 60, because that's 6 times 10. X, bring it down 1 to the 5th. That's the power rule up to that point. The derivative of sine of x, we know, is cosine of x. Be sure you write these down for question number 1. Got a little emotional. Hold on. Oh, okay. Oh, the derivative of cosine of x is negative sine of x. Those are 2 trig ones we have so far. E to the x is the best of all derivatives. The derivative of e to the x is e to the x. Any exponential reappears. Now remember, any other exponential has some baggage it carries with it. So the derivative of 2 to the x is 2 to the x times the baggage it carries, ln of 2. It's always the ln of the base. And the derivative of ln of x, I see ln, I see the word line when I start. Its derivative is 1 over x, or sometimes on multiple choice, x to the negative 1. You need to be able to identify both. So that is the answer for question number 1. The only other rule we have right now is the chain rule, where I'm going to write it out fancy first. F of g of x. If we have that function, its derivative is the derivative of the outside. Don't mess with the inside. Times the derivative of the derivative of the inside function, g prime of x. An example of which is the following. So I personally don't think the way this rule is written kind of helps us out. If we have the sine... Oh, by the way, this is question 2. Please write down this rule and the example. The sine of x squared, the derivative of the sine of x squared, is the derivative of the outside. Derivative of sine, which is cosine of x squared, times the derivative of the inside, which is 2x. Okay. So this is question 1 and 2. These have been our rules up to this point. And now we're about to add another rule. And it's going to have to deal with products. Let me show what I mean, product. So let's say I had x to the 7th times x to the 3rd. And please write this stuff down for Q3. Okay, so for question number 3, I'm going to take the derivative of this product, x to the 7th times x to the 3rd, but I'm going to check it at the same time, because I know x to the 7th times x to the 3rd equals x to the 10th. So I know these 2 statements are the same, okay? So the derivative of x to the 10th is 10x to the 9th. Okay, so I'm going to go over to the other side now, to the product rule. I'll do this in red. I'm hoping that the derivative of this statement is the derivative of the first part times the derivative of the second part. And hopefully it gives you the same answer as this one. Let's see. So I get 7x to the 6th times 3x squared, which equals 21x to the 8th. Uh-oh. The derivative of the product of 2 things is not the same as the derivative of that, which means that my hope is an epic fail. Fail. My hope for this rule didn't work out the way it was going to work. Oh, that's too bad. Okay, let's try something else. Okay, let's put the same problems up there. Now, this is not question 4. Question 4 is coming after this. So I'm going to go x to the 7th times x to the 3rd. And I'm going to put its equivalent on the other side, which is x to the 10th. Okay. I know the derivative of x to the 10th is 10x to the 9th. So the real question is, how do I deal with products? Well, remember with the chain rule, how we combine the derivative of one thing with the original for the other? That's going to be the same for when we have a product rule. And product rules are going to work the following way. We're going to label either part u. I'm going to label the first part u. It's like two things multiplied together. This problem is really u times v. So I'm going to label this u. And then I'm going to label this v. Okay. Now, just so you know, if I put u here, I'm going to let you know that v, I'm going to put u and v next to each other, and I'm going to let you know that v is a fabulous dresser. Wears fancy hats, nice suits, it's a tie, by the way, and a nice blazer, okay? And every time U sees V, he wants to tell V how good he looks. So guess what U says to V? These are calculus terms, so this is what U says to V. U wants to let him know how good he's looking. In calculus, prime means you're looking good. So U says, U prime, V? An exclamation point. Okay? So the rule for the product rules, we divide it up into two parts. The derivative of a product of two things is U prime, V, plus u v prime. It's just the derivative of the first times the second part plus the first part times the derivative of the second part. We're always just multiplying a part with a derivative part. And I'm going to show you how we work these problems out. I'm going to skip past this for a minute, come down to here. So if u is equal to x to the 7th, and this is the best way to write them on down because it makes the problems pretty much work out straightforward. That means u prime is the derivative of that. U prime is equal to 7x to the 3rd. If v is equal to x to the 3rd, then v prime is equal to 3x squared. And how are we going to combine them? We're going to combine u prime and v, and then u and v prime. So u prime v is going to be, oh, I wrote that down wrong. You got me. You almost had me. You got it quicker, though. 7x to the 6th. Nice try. So u prime v is 7x to the 6th times x to the 3rd plus u is x to the 7th times 3x squared. Now, what we're hoping, and this answer is correct and does not have to be simplified, but is that answer really equal to this answer right here, even though they're in two different forms? Let's take a look and see. So 7x to the 6th times x to the 3rd is the same as 7x to the 9th. And the next one is equal to 3 times x to the 9th. And if we add those together, we get 10x to the 9th. So the derivative of the product rule matches the derivative if I combine it together first. So we now have one new rule, and it's called the product rule. And here's the fancy way of writing it. And you write if f of x is equal to u times v, then f prime of x is equal to u prime v plus u v prime. Divided into two parts. Okay, so your problem you're going to do for number 4 is the following. So for number 4, I'm going to write down y is equal to the sine, and notice the sine of x squared times x to the 5th. So for problem number 4, what you're going to put down is, let's define our u. Our u is going to be this term right here. squared. And our v is going to be the other term. V is going to be equal to x to the fifth. So the question is, what is our u prime? So it's going to be the derivative of this, of the u. And what's our v prime going to be? The derivative of that. Please be aware on the u, you're using the chain rule in there. And then what you're going to do is you're going to cross them. And you're going to write down u prime v plus u v prime. Write them on there and fill them in for number 4. Now that we've done that one, I'm going to evaluate tomorrow if you understand those rules. We're going to practice them, and we may even get our SPQ for these right out of the way if you understand what's going on. And if you don't, we'll just do it again. Okay? Have a good day today, folks. I'll see you tomorrow. Take care.